Ladies and gentlemen, welcome to my shop. Welcome to my channel. My name is Keith and I'm your host. Before we get started, class, how about the Pledge of Allegiance?
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Peace! Peace! Amen.
Here we go again with a new project. This is actually the second project we've received from Heritage Restoration. Both of them being bell yoke orientated, and that's what this is. This is a school bell out of a antique schoolhouse, I believe in Westport, Connecticut. And our proposed repair on this, or refurbishing on this, will be the pivot points and all the hardware, because nuts and bolts that bolted this together are no longer made the same way. So we're copying the design of the original hardware, and we've already started cutting out some of the bolts, and we'll get into that as we're going with the project. And we have some up here that bolt the bearing caps on the pivot yoke itself. So basically you have one each carrying on each side, and then the bell's mounted in here. Of course, this is upside down. This is the top. This top section is kind of counterweighted for the bell, because the bell weight is actually quite a bit. And this side here will carry the rope pulley, and the rope pulley mounts on the side here and has a stationary bolt there. I believe it's, yeah, I haven't tested this yet. It's got a slight bit of play there. I'm going to clean it up, and we're going to really kind of look at it. And I'm not sure if we're going to weld build that up and repair that, or clean it up and let it go and make a new bolt in here, making sure that it's fine. It does have to have the threaded hole for the retainer bolt in here. That has to be done, but we're not sure about the bore itself. That actually still feels pretty good on there. All right, our main concern is what to use for alloys, and can we actually machine this diameter. These caps, and actually I'm going to grab this, and this fits in here. Of course, this will be on the top, but this gives you the whole idea of the package deal here. And this is quite a bit worn out. This is cast iron. This is cast iron, but through the center of the cast on both points, this is a regular steel insert that's put in there. So this is steel, and they ran steel on cast and had a little oil hole in the top. Cast is a good bearing material for steel, as long as it's lubricated. And for as old as this bell is here, you can see that all the components are here. They're not totally gone. So we propose to braze this part of it up, because braze is the proper alloy to add to and act as cast does, bearing material, and also joins it and doesn't crystallize it, and makes it very machinable, compatible materials. This has got to be steel, so this will be TIG weld, built up and then returned. Now, to do that, this has to fit in the lathe, and the very first thing we're going to have to do is we're going to have to go see if this actually will go in the lathe. If it goes in the lathe, then our job is going to be a little easier. Let's go check that out. Okay, let's see. I think we're going to chuck on this side here first, because it's machined. The other side is not machined. And I don't know how true something like this is. This is kind of, my chuck is like slightly bell mouth. I might actually have to take these jaws off and use the inside ones there. Okay, now, yeah, making sure this thing is in neutral. Are we clearing? Hey, we're clearing a little bit less than my pinky. Okay, now you see that too. You see how that much weight off to one side. Okay, now I'm seeing a little bit of this movement around here, but that's because we're still loose in the jaws here, because these are my 3 jaws bell mouthed a little bit. Okay, or there's a little bit of difference on the yoke itself, which I haven't considered that. I'm gonna try there. Oh, that feels a little better. Let's see. That's running a little bit better down at that end. We are probably gonna have to set up this end somehow, zero this in, and put a steady rest in here and skim a good surface here. And we're gonna have to then probably carry this into steady rest and put a good center in on this side here. Kind of my first thought. Let's check it out. All right, I got the other camera here on the compound, and I'm kicking it on here. Now we'll worry about counterweight and stuff like that. Right now I'm kind of turning it, this lathe is heavy enough to where it's not affecting it too much. All right, if you stare right down into that corner where that, you can see where that buildup is, you can sight it, and you can actually see that that diameter is running perfectly true. A little bit of this is worn out, and one side of this is worn out. But right there in the middle of that, that's running pretty damn true, and also the outside of this one in here is running pretty damn true. So we'll be able to skim this diameter right here. But I'm not going to quite do it yet. We got to go concern ourselves with the other end. Okay, now I've got the camera here giving a good look in between the jaws. Now you can see the pivot for that we're going to be building up and turning over here. That is running out slightly. All right, and of course you can see this diameter here, how irregular it is, and when it was choked all the way up, that's why it was forcing the other end not to run true. So what I want to try to do is get out here and get on that little diameter right there and see how it's running in that position there. It's going to be a little bit of a gingery grip right there on the 3 jaw, but let's see if we can do it. I think I'm in the right gear. Okay. No, we're in no gear. Okay. All right, there we go. All right. Now we're chucked up on the pivot itself out there, which is running pretty darn true. If you look in through the jaws. All right, and now you can see this boss right here is kind of all over the place. All right, we have a block and a V block underneath that section and this section over here. This diameter here is within 20 thousandths of this. You're about 20 thousandths between there and there. We've taken the square up off the table edge up to the part in both these locations. So our axis is straight in line in horizontal and longitudinal directions there. We went ahead and put our tap follower in here, and we brought it in to the point. And we're taking this out, and this is a 7/16 little round stock. And we chose that because this little boss coming out here is 7/16 of an inch in diameter, and we were verifying the alignment side to side by visually sighting that as well. All right, I'm going to bring a camera in here so we can get a good look at the wear on this pin that sticks out, the pivot point. All right, I set up my Note 10 Plus here so that we can get a really nice close lineup on this. Now you can see that this is definitely in line with that boss right there, and that there is more wear on the whole underside of this. Remember, this rocks like this with contact right now. All right, over here on this side, outside edge, you know, inside here but outside surface of the main landing here, you can see the majority of the wear. This original diameter was 3/4 of an inch by my best guesstimation, and right now we are 645 thousandths there. If we were to go side to side here, we're looking at about 720, and I just think that there's been rusting and shaling of the whole diameter, and then the excess of wear on the bottom from the age of this and the amount of times it probably rusted up and then shaled out that rust when it had a little motion or movement when they used the bell. I don't really want a real small center drill, but I don't want a really big one either, so I'm choose a number 4. Just a little bit more. I'm going to say 3/4 of the width of the number 4 center drill. There we go. I like that. Okay, let's endo that thing. All right, here's the other side. Now this diameter here was 3/8 on this side, but it's still measured across, up and down, side to side the same. And then we just put a tool bit in there of 3/8, and we kind of like eyeballed it that way. So here we come. And the center little dimple there, that center little dimple kind of lined up as well, so all right, we've got centers in there now. All right, we brought our yoke in here and we set up the plasma table. We burned out a flange. I don't know if we're going to need more. I didn't know if we were going to run 2 bolts or 4 bolts or whatever. But as practice, it was an oddball pattern, so I was practicing to be able to lay it out and cut it out, and I was successful on that. This is a piece of solid, and this is a piece of flat bar just to join. I kind of played with this distance to center and up to here, and how much I can add out to here, which would take up this area here. So I have something substantial to bolt to. The whole idea is to create an offset of weight opposite of the weight that's off center, so that you have something that doesn't lobe in the lathe. All right. How are we going to judge that or get that as close as possible? We're going to use my right rollers here, and That's still a little bit warm. I had to run down and get some hose clamps because I was in a spot where I couldn't remember where I stored mine since the move. So there's moments where I'm not sure where things are at yet. So the container's got things in it and a couple other areas. All right. So we got the rollers here. Now we need to create enough weight on this side here so that it's pretty well balanced, almost like the scale, only we're using the rollers for the pivot. All right, I was using these billets of Babbitt here to hold the plates down on the fuel tanks I'm working on. Now I put that up here, and then I kind of get, it's almost right there. So I'm going to go ahead and hose clamp this on in place and then get a good feel of it. If it's darn close, I'm going to let it fly like that. So this is just, I think I'm going to be lucky. So we'll go ahead and put this up here and okay, we're going to put hose clamps around here. All right, I think we're pretty well equal to its weight there. All right. I needed some hose clamps, and I wasn't quite sure what length I need, so I went down to Napa. They had these things here, which were, 45/311 millimeters. And a little extra, right? Okay, and I think I want to put the band out here like this. All right. And we're just going to wrap that around. We'll tape it after we increase the tension on here. Okay. All right, let's go ahead and place this on the rollers again and see. It's a little heavier than it needs to be. Do we find something just a little bit less and put on there? Let's see what we might have for diameter. Okay. Okay. 20. Okay, we're gonna need something about in between the two sizes right there, right? Okay, you can see all by itself the amount of weight that will automatically, as soon as you're past center, it'll go. All right. So when we run this, we can hear the lobing on the gearbox. And when you feel the lathe, you can actually feel the lobing as well. All right, let's put it back in neutral. All right, we're gonna add our piece here, and then we're gonna swing it around by hand. We're gonna make sure that we are clearing, because I'm not 100% on that. All right. I think that's a sign that it's going to be close enough. Let's tighten these on. And put it neutral. All right, I think now we can start to think about where we're going to cut and prep it for its welding and brazing. We're all set up, and we retensioned our clamps. We took the tape off and retightened them and put them back on here. The first initial start up here, I could see them slightly move, so I checked the clamps, and they did need to be tightened up a little bit because they started creating the shape of the rounds and the square here. We're gonna go ahead and put our tool bit in here, and we're gonna skim the OD of these two large diameters here for the pivot and kiss this face. Then we're gonna into it. We're going to do the same thing over there. After we do that over there, we're going to skim the diameter that the rope pulley sits on, and or turn it around and do this diameter, and then flip it and do the next diameter. We want to go for the two small diameters, then we're going to go for the two larger diameters. The chances are that if we skim this diameter here for the rope pulley, we got to do brazing on that female on the wheel, the rope wheel itself. We might as well go ahead and braze that bore and rebore that to fit here, and we got to increase one or the other, and the other one already needs to have brazing work to redo the threaded hole so that it'll seat in here properly. And if we just make this one round, we can just eliminate it and only do the TIG welding for the steel rod that goes through the cast on each end. All right, I'm going to grab my tool bit, and we're going to start off at this end. There we go. I'm going to go ahead and I'm going to do the feeding myself. And first off, I'm going to do is I'm going to come in here and I'm going to touch off, and I'm just touching the outside of that. I'm going to set 0 here on my cross feed, and I'm coming over here. Of course, I'm staring down inside there, making sure that I'm going to clear. And I'm coming in until I touch there, and I'm 7 thousandths on my dial. Okay. So come back here, and I'm going to go ahead and I'm going to give it. I'm going to set 10 from where I touched off here. All I really want to do create a round diameter on both of these surfaces here so that I can chuck up on that round diameter when we flip it in for in. And I want to come out and I want to touch that cast material just to make sure that I'm making it square. And we can take it a couple more, just till it's clean. This will let that diameter or that face rest right against the outside of the jaws. And of course, the jaws will be able to touch. All right, here we go. We're gonna come back and we're gonna take another 10. I'm gonna set up bottle feed now. Okay, we're gonna stop and look at that. Now I want to look at the wear in relationship to how the bell hangs. Okay, the bell hangs just like this. We're taking a cut on the top because it doesn't wear. The underneath area is where it wears. Now we are turning all the way around on this inside right here, but right out here, it's just barely skipping right there. We're gonna go ahead and we're gonna take another 10. And get a feel where we're at here now. It was like 1 1/8 inches or so. We're down at 1.25 inches. Okay, this will be it right here. I'm turning slow and I'm not really adding any cutting oil because I want to keep it clean to be able to weld to this material without having any oil bubbling up into it. That's good. We're getting a round diameter there now. It's picking up the holiday, but out at the outside edge we're round, and when we get into that inside diameter we'll be round there as well. We'll have a substantial diameter to put in the chuck. Okay, we're going to feed out. Yeah, nice. We're all the way around there. All right, we're going to endo this part now. We're going to do the same thing to the other side. Okay, this was sliding side to side on me here. And we're gonna put a wrap of tape to where it will go off to the side somewhat. There we go. We'll do the same thing over here. There we go. Because I'm going to be doing the same thing, and I like grabbing underneath here. That was pretty smooth. Alright, before we go, we're going to roll it over one more time, just making sure we're clearing over here. We got this here that's got a concern on their clearing now too. Alright, let's give it a spin. This, you know, this side is wobbling more, but it's because there's more wear on the bottom of this side because of the weight of the rope. The pull of the rope, everything that is on the other side has the weight of the rope plus on this side. Okay, that's about 5 thousandths there. We're going to give it the 10. And this is because the dial and the tool bit have not changed from what we were using on the other side. So our diameters are falling right into place here as well. Now I'm feeding this in by hand on this side here. I think another 10 right there. So basically off of from one side to the other side here, we've taken about 45 to 50 thousandths split between both faces. Use my travel dial and are endoing it. Minus, we probably took off a couple high spots when we turned it around. Kind of compensated for that. All right. All right, we're going to come into that 20, give it an auto feed. All right, last cut here. Okay, we're going to feed out. I think we're all set up here now. Let's I think I'm going to go a little slower for this operation, so I'm going to drop this down a little bit slower. And I'm going to stay off of that. I'm going to hand crank this in, and I just want to make sure that everything is going to swing. We're not catching or clinking. All right, that's everything gone into that diameter there. I'm going to go in and just touch off at this area right here. Okay, that's 0. I'm going to set my dial at 0. Let's come out here and we're going to come in till we touch. Okay, and that's like 10 more than 0. Okay, so I'm going to go ahead and I'm going to start right there at 10. This diameter is not only to drive or hold the pulley that controls the bell, but this surface is also going to be used for the steady rest to do the turning on the end of the shaft. Because we're going to be doing a much heavier cut, and we're also going to be plunging into that little valley area. So we do need a more rigid support out here on the outside when we're doing that finished turning on the steel. Not too bad of a finish. It has a little bit of pattern to it, resonance. How can it help not to? The thing is exceeding all the norms. We just got a little tiny bit left there. Let's take another 10 and see if we clean up there. Looks like we might have enough there for a steady rest to ride. Awesome. We're all finished with our second side. So this is open air, okay? And we've taken the roughness off of it and made it true so that we'll be able to finish this diameter after welding. So we'll be able to hold this in the steady rest. This will stick out and we'll be able to machine these diameters right here. Okay, now I'm sure that there's going to be a little bit of movement out here on this outside edge, and when we put this in the steady rest, that center right there is probably not going to be running true because the weld is going to pull this somewhat. All right, so we may have to single point our centers in the end if we need to use them again, but they have served their purpose to getting to where we're at right now, to where we'll be able to hold it with the 3-jaw on one end and steady rest it here and turn this diameter at both ends.